This is the entire 2024 AP Calculus BC Free Response section, all 6 questions, solved start to finish. A series that fools you at the boundary, a particle in motion, and the slope field nobody finishes in time. Let's solve every one. Here's the plan. 2 questions allow a calculator, 4 do not, 6 in all. We'll work a cooling rate, a moving particle, a slope field, areas under a graph, arc length with Euler, and a Maclaurin series. Then a quick recap. Question 1. Coffee cools in a cup. A decreasing function c of t gives the temperature in Celsius with a table of values at t equals 0, 3, 7, and 12 minutes. Part A. Approximate c prime of 5 with the average rate of change on 3 to 7. That's 69 minus 85 over 7 minus 3 negative 16 over 4 equals negative 4 degrees Celsius per minute. Part B. A left Riemann sum with the 3 given subintervals widths 3, 4, and 5 gives 3 times 100 plus 4 times 85 plus 5 times 69, 985. Divided by 12, that's the average temperature over the 12 minutes. Part C. Now c prime equals negative 24.55 e to the 0.01 t over t. The temperature at 20 is c of 12 plus the integral from 12 to 20, 55 minus 14.67, about 40.33 degrees. Part D. The second derivative is a positive constant times e to the t term times 100 minus t over t squared. On 12 to 20 every factor is positive, so c double prime is positive. The temperature is changing at an increasing rate. Question 2. A particle moves in the plane. Its velocity components are x prime equals 8t minus t squared and y prime equals negative t plus the root of t to the 1.2 plus 20. At t equals 2 it sits at the point 36. Part A. Speed is the magnitude of velocity. At t equals 2, x prime is 12 and y prime is about 2.72. The root of 12 squared plus that squared is 12.305 centimeters per second. Part B. Total distance is the integral of speed from 0 to 2, the integral of the root of x prime squared plus y prime squared. The calculator gives 15.902 centimeters. Part C. To get y at 0, start from y at 2, which is 6, and subtract the integral of y prime from 0 to 2. 6 minus 7.17 is negative 1.174. Part D. In the first quadrant y is positive, so the particle moves toward the x-axis exactly when y prime is negative. Solving, that happens for t between 5.222 and 8. Question 3. No calculator. Seawater depth h satisfies dh dt equals 1/2 times h minus 1 times cosine of t over 2 with h of 0 equal to 4. A slope field is given. Part A. Sketch the solution through the point 0, 4, follow the tick marks, rising then leveling off as the field flattens. Part B. A critical point needs dh dt equals 0. Since h is greater than 1, the h minus 1 factor can't be 0, so cosine of t over 2 is 0, giving t equals pi. The derivative is positive before pi and negative after, so it's a relative maximum. Part C. Separate variables. The integral of 1 over h minus 1 is sine of t over 2 plus a constant. With h of 0 equal to 4, the constant is ln3, so h of t equals 1 plus 3e to the sine of t over 2. Question 4. No calculator. We're given the graph of f, a smooth hump on the left with area 12 in the second quadrant, then a straight line on 0 to 7 through f equals 2 down to negative 1 at x equals 6. Part A. G of x is the integral of f from 0 to x. G of negative 6 is minus the region's area, negative 12. G of 4 is the triangle 1/2 times 4 times 2 equals 4. G of 6 is 4 minus 1 equals 3. Part B. G prime is f on 0 to 6, f equals 2 minus x over 2, which is 0 at x equals 4, so the only critical point of G is x equals 4. Part C. H of x is the integral of f prime from negative 6 to x, which equals f of x minus f of negative 6. So h of 6 is negative 1 minus a half, negative 3 halves, h prime of 6 is the line slope negative 1 half, and h double prime of 6 is 0. Question 5. No calculator. F is twice differentiable, f of 0 is 0, and a table gives f prime as 5, 6, and 0 at x equals 0, pi, and 2 pi. Part A. H of x is the integral of the root of 1 plus f prime squared. By the fundamental theorem, h prime of pi is the root of 1 plus 6 squared, the root of 37. Part B. That same integral from 0 to 2 pi is the arc length of the graph of f, the length of the curve itself. Part C. Euler's method, 2 steps of size pi. From 0, slope 5 gives y equals 5 pi at pi, then slope 6 gives 5 pi plus 6 pi, so f of 2 pi is about 11 pi. Part D. Integrate t plus 5 times cosine t over 4 by parts. With v equals 4 sine t over 4, the answer is 4 times t plus 5 times sine t over 4 plus 16 cosine t over 4 plus c. Question 6. No calculator. The series question. F of x is the sum of n plus 1 x to the n over n squared 6 to the n with radius of convergence 6. Part A. At x equals 6 the powers of 6 cancel, leaving the sum of n plus 1 over n squared. That's bigger than 1 over n, and the harmonic series diverges, so by comparison the series diverges at x equals 6. Part B. At x equals negative 3 it's alternating. By the alternating series bound the error is at most the fourth term 5 over 256, which is less than 1 over 50. Part C. Differentiate term by term. The general term of f prime is n plus 1 x to the n minus 1 over n times 6 to the n, and differentiation keeps the radius of convergence at 6. Part D. For g, the ratio test gives x squared over 3. That's less than 1 when x squared is less than 3, so the radius of convergence is the root of 3. 6 questions, a cooling rate, a moving particle, a slope field solved exactly, areas under a graph, arc length and Euler, and 2 series at the edge of convergence. That's the whole 2024 paper. That's the entire 2024 paper, every step matched to the official College Board scoring guidelines. Subscribe for the 2025 exam solved next and tap the card on screen to keep going.